Hey there, Stage Math students. Welcome to Homework 4.6, Simplifying Algebraic Expressions. You watch today, you check off. Calculators are okay. This is practice and it's due tomorrow. So the biggest thing with this homework, understanding that when you simplify an expression by combining like terms, you are doing nothing but adding. So you're going to have to remember your rules for integers, which is same signs, add, keep. Different signs, subtract, more. And every time you see subtraction, you are going to want to KCC, even in the answers, because if you don't do it, you might be really confused and be like, wait, this addition problem doesn't match up with this problem because it's subtraction. But remember, adding the opposite is the same thing as subtracting. So let's try a couple of these together. So how you show work is exactly like how I've shown in number one. Underline the like terms, double underline the like terms, and then match up your answer. So number three, go through, see if there's any subtraction. I see it, boom, plus a negative. Now let's find like terms. So -5 is a constant and -1 is a constant. That is an SSAK. That gives me -6. 6n and n are like terms because they got the same variable. N all by itself has a coefficient of 1, so I'm really doing 6 plus 1, and that gives me 7n. So I'm looking for -6 plus 7n, and there it is, D. All right, number 5. Go through any subtraction, yep, right there, plus a negative. So look for like terms. I've got -8x and -9x, SSAK. That gives me -17x. And then I got this constant +8, so +8 goes all by itself. It doesn't have a like term. Can't combine these guys because this one's got an x and that one doesn't. So B is my answer. If I were you, I would stop. I would try and do 2 through 8, show all work. 2 through 6, show all work like I have. And again, remember, anytime you see those pesky subtraction signs, change them to adding the opposite. It's going to make your life a lot easier. And remember to do it also in your answer choices as well. We'll be doing nothing but adding when we're combining like terms. All right? So take a look at number 7. Remember, like terms are the same variable and same exponent. So you cannot combine something that has the same variable but a different exponent. So like 6v squared cannot be combined with 2v to the third because they got different exponents. So you want to look for the same variable and same exponent. So this is how you show work. Let's take a look at number 9. Plus a negative, right? So we're looking for, are there any solo v's out there? Yes, there are. 5v and 3v. That is 8v. Right? And now let's look, are there any v to the thirds out there? -3v to the third and 8v to the third. -3v to the third plus -8v to the third. Don't worry about adding exponents or anything like that. Just look at the coefficients. So what's -3 plus 8? That's DSSM. That's plus 5, and then put down v to the third, right? So you'll notice that the answer is actually flipped. It's 5v to the third plus 8v. Usually they write answers in descending order with the highest exponent first. But this is the commutative property anyway. It doesn't matter what order I put that in since it's addition. So B is our answer there. So again, only add coefficients. Coefficients are those big numbers in front of variables. There's no need to add exponents. They stay the same. So go to the back side. We've got 4 questions here that are kind of something that you might see on Aspire or something like that. So which of the sets of terms below does not include like terms? Okay, so 9m, -9m, 7m, those are like terms. These are all like, right? Like terms are same variable and same exponent, right? So those all have m, and they all have no exponent, so we're good to go. 30, -25, and 25. These are like terms. They're all constants, right? They have no variables, no exponents. We're good to go. 1p, -7p, 7p. Those are like terms. They all have p, right? And no exponent. So 6x, 6y, 6z, these are not like because they got all different variables. Okay? Number 13, it says, which of the following is an example of a set of like terms? Again, we know that those are same variable and exponent. 17y, y, and 17. This one needs a y to be a like term, so nope. 18, 21g, and 24 needs g in order to be like terms, so that's out. 15x, -x, and 33x, those all have x. They all have the same exponent. Those like terms, this one had xy, not like terms. Okay. At 14, I'm going to help you out a little bit because remember, perimeter means to add all sides. So if you've got expression of 3x plus, we'll call it negative 2 there, that also means that this side is 3x plus negative 2. And if this is 2x minus 8 or 2x plus negative 8, that means this side is 2x plus negative 8. So to find the perimeter of this, you just need to add all the sides. So 3x plus negative 2 plus 2x plus negative 8 plus that side 3x plus negative 2 plus this side plus 2x plus negative 8. So now that you've got this entire expression, just go through and get your like terms, right? So 3x, 2x, 3x, 2x, those are like terms. And then you got negative 2, negative 8, negative 2, negative 8. Those are like terms, right? All these constants can be added together. All these variables can be added together. It's not just the negative 2's that get added together, right? The negative 2 and the negative 8 and the negative 2 and the negative 8 because they're all constants, okay? So given that, we've got 5x. Sorry, no, wrong, my fault. We've got 10x, because 3 plus 2 plus 3 plus 2, 10x, plus, this is negative 10, this is another negative 10, negative 20. So that is D as your answer. I'll let you do 15 because it's very similar to 14. Best of luck. Call me if you have questions.